Hello students. Today we're going to be covering factoring differences and sums of cubes. A sum of cubes is exactly what that says. It's a sum, meaning we would be adding terms that are perfect cubes, meaning we can take the cube root of these terms, or that we can multiply 3 of the same number and get that number. So in other words, a perfect cube might be 1, because 1 cubed is 1 times 1 times 1. 2 cubed is 8, so 8 is a perfect cube. 3 cubed means 3 times 3 times 3, so 27 is a perfect cube, and so on. So these are going to be numbers that we will end up taking the cube root of. So if I ask you the cube root of 27, you need to know that it equals 3. Okay? So there is a pattern to finding the factors for a sum of cubes. First of all, we start off with a binomial factor and then a trinomial factor. So that means there's going to be 2 terms here and then 3 terms here. Recall, as I taught in class, that the sign, meaning whichever you're taking, if you're finding the factors of a sum of cubes, then this binomial factor will carry that same sign. Your other signs will be minus and plus. Okay? So this will always have the same sign. It will always have the opposite sign here. And this, that sign there, will always be positive. Okay? So to complete these factors, we first want to think about taking the cube root of a cubed. So if I want to know the cube root of a cubed, I'm going to think, well, that's 3 of what factor? Remember, we've already covered radicals. So if you have 3 a's, the cube root means you have one group of 3 a's. So the cube root of a cubed is a. Likewise, if we have b cubed but want to find the cube root, we would be looking for 3 of the same factor, in this case 3b's, so the cube root of b cubed would be b. So these come from finding the cube root. And this is going to come in handy because you'll hear me say it a lot often. Cube root, and then the pattern here. To find the first term in your trinomial factor, we simply square the first term of our binomial factor. So we're no longer looking at our original polynomial. We want to look at this factor. So if we square a, we get a squared. Then we find the product of these 2 terms, and in alphabetical order, list them as a, b. Next, we find the square root of the last term, which would be b squared. So though this device that I use to help you remember won't help you know which terms, it'll hopefully click when you hear it. So you'll hear me say often, cube root, square, multiply, square. Cube root, square, multiply, square. Cube root of the first term in your polynomial, cube root of the second term. Then you square the first, then multiply these 2, and then square the last. So square, multiply, square. All right? So I'm going to slide this down and we're going to talk about a difference of cubes. Very similar, almost identical. Really the only thing that will be different will be the sign pattern. So we still have a binomial times a trinomial, but similar to before, the sign in our binomial will be the same as whatever we have in our polynomial. So since this is a difference, we'll have a minus here. So one thing I want you to recognize is that both for a sum of squares, this is our sum, this being our difference, that you have one minus sign in the factors. Likewise, you will only have one minus sign in the factors for a difference of cubes. So since this is always the same, just like for a sum, our binomial factor always has the same sign, notice that, then we've already used up our minus. So by default, the other two have to be plus signs, okay? The pattern is exactly the same as before. We take the cube root, oops, I apologize, square the first, multiply, and square the last. So these you are definitely going to need to memorize as the factors for a difference and a sum of cubes. Okay, so memorize those. So let's take a look at our first example. I would like for you to factor x cubed plus 125. So when I first ask you to factor this, what I want you to always still consider is, do we have a greatest common factor? Because we do not, we will move on and try to find another method. We have two terms that appear to be cubes. If you take a look at this exponent 3, it's a cube. We can look at 125 also and think about that being a perfect cube. Remember, I asked you to memorize your list of perfect cubes already. But if you forget how, remember that you can go to Math, choose option 4 for cube root, type in 125, and we see that it is a perfect cube. So that means 5 times 5 times 5 equals 125. So since we have verified that this is now a sum of cubes because of the plus sign and because these are perfect cubes, we can now establish that our factors should contain a binomial and a trinomial. The next thing we do is fill in our signs. Remember from your sign pattern that it's plus, minus, plus for a sum. So plus, minus, plus. The cube root of x cubed is x. The cube root of 125 is 5. So we've got our cube root. Now we want to square this term, multiply these terms, and square. And that is completing the pattern. Of course, we should verify that this is true. So let's, on our home screen, type in x to the third, remembering to use your caret top key located right here above your divide key. So x to the third plus 125 and hit enter. And then type in your answer, x plus 5 times x squared minus 5x plus 25. When we do so, we can see that these are equivalent expressions, telling us that we do have now the correct factored form. Okay. Next, a second example, let's take a look at factoring a difference of cubes this time. So now we've got a sum, now we're going to do a difference. Remembering that the only thing different is the sign pattern. So again, first look for a greatest common factor. It does not appear that there is one, so I'm going to write my parentheses for a binomial, then a trinomial. I'm going to follow my sign pattern up here for a difference of cubes, which is minus plus plus. That you should memorize, minus plus plus for a difference. So under difference, I'll put minus plus plus. And then under sum, why don't we come up here and say plus minus plus. So maybe you'll remember that. Your sum is plus minus plus, difference minus plus plus. Okay? So next, again, we want to take the cube root of 8x cubed. So that would be, remember, 2 times 2 times 2 times x times x times x. So it's 2x. The cube root of 27 is 3, because 3 times 3 times 3. Next, following that pattern, cube root, square the first term. That'll give us 4x squared. Multiply 2x times 3. See how, since we've determined our sign pattern already, we don't have to consider if it's 2x times a negative 3. We already know our sign should be plus because of the pattern built in for a difference of squares. And next, we square the last term, so 3 squared is 9. Okay? Again, we should check that in our calculator to make sure it's equal. They're equivalent. So I'm going to type in, oops, sorry. Type in 8x to the third minus 27. Oops. And then type in our factors. And again, we get the same value, so I feel pretty comfortable saying that that would be correct. So you need to remember the sign pattern, and remember that little chant there that I use. Cube root, square, multiply, square. It comes in handy. So next, let's take a look at this example. 2x cubed plus 128y cubed. When we take a look at this, again, the first thing we should do is try to identify if there's a GCF we should pull out. In this case, because 2 and 128 are both even, we do want to recognize that we can pull a 2 out. There are no variables that they have in common. So if I take that 2 out there, then that's going to leave me with x cubed plus 64y cubed. Well, now that I'm here, I recognize, oh, my exponents are 3. Recognize, though, that we can have a cube root if our exponents are multiples of 3. So as long as we have multiples of 3, so that could be x to the 6th or x to the 9th or y to the 12th, as long as they're multiples of 3, we can take the cube root of that. However, our coefficients, this understood 1 and this 64, should be perfect cubes. So since they are, hopefully you remember the cube root of 64. If not, remember you can go to Math 4, type in 64, and yes, it is a perfect cube. It's going to be 4 times 4 times 4. So next we want to say, okay, well we know this should result in a binomial times a trinomial factor. So the cube root of x cubed is x. Oh, I should go ahead and put in my sign pattern. So do you remember what it is for sum? Plus minus plus. So the cube root of x cubed is x. The cube root of 64y cubed is going to be 4y. Then to get our next term here, this first term in our trinomial, we will square, multiply, and then square the 4y. No, I should have left a little more room. So we should have 2 times x plus 4y times x squared minus 4xy plus 16y squared. So hopefully you're getting a little more comfortable with this process, because this is not one that we would type in our calculator since it has both an x and a y. So otherwise you would need to multiply it out and check your work there. But this is completely factored. Notice, just like all the other factors, when we get through, any factors in parentheses should be prime, as in x plus 4y should not have any common factors other than 1. X squared minus 4xy plus 16y squared should have no other factors other than 1 in common. Okay? And lastly, we're going to look at a little bit of a different case here. Number 4. Let's consider what happens if we have exponents larger than 3. So I just referred to that in example 3, that the exponent could still be a perfect cube as long as the exponents are multiples of 3. 6 is 3 times 2, so it is. So when I take a look at this, remember we've also covered differences of a difference of squares. And when I look at this, remember the criteria for being a difference of squares was that you had two terms where there was a difference, where for the variables were even. So because they're both even and they're multiples of 3, it's actually both a difference of squares and a difference of cubes. So generally, we like to factor a difference of squares before factoring a difference of cubes. Obviously, it is a lot simpler. So remember, the differences of squares is found by taking the square root of each term, where each binomial factor, one will have a plus and one will have a minus. One's a sum and one's a difference, Remember that if we were to multiply these out, that our middle terms would cancel out. So what we want to do is take the square root of x cubed, x to the 6th. So let's consider what that means. If we take the square root of x to the 6th, remember when your index is 2, you're looking for pairs of the same factor. We can actually form two groups of x. So if I bring these out, I now have x times x, or x squared. I apologize, I said that all backward. If we are taking the square root, I said it right, but I wrote it wrong. We're finding groups of 2, and we have 3 groups. So that's x times x times x, or x cubed. So that means we split up our exponents. Remember, just like you learned in your lesson on differences of squares, we split this up, and this is going to be x cubed, and this term x cubed. Remember, when we multiply together, we add exponents, so 3 plus 3 would give us 6. And then our y to the 6 is y cubed. Well, let's take a look at what we have now. It appears here that we have a sum of cubes. It appears here that we have a difference of cubes. So now we need to deal with that aspect. So I'm going to take this sum of cubes and deal with it first. So I know that if I'm factoring x cubed plus y cubed, I get a binomial times a trinomial like we just spoke about. Because this is a plus, my sign pattern is plus minus plus. The cube root of x cubed is x. The cube root of y cubed is y. Then we square, multiply, square. So that takes care of the factors for the sum of cubes. Next, we want to factor the difference of cubes. To do so, again, remember your sign pattern, minus, plus, plus. And basically, because these are the same, the only thing different is the sign pattern. So the cube root of x cubed, again, is x. The cube root of y cubed is y. Then we square, multiply, square. Notice nothing else can be factored. They're all prime. So we're actually through now. So we want to be cognizant that if we have exponents higher than 3, higher than 2 or 3, that we consider the possibility of having differences of squares or sums and differences of cubes. And that concludes our lesson. Thank you.